This is a demonstration homework for ECE MAE 535, presented by Bao Trons and Brian Casada. The all topic is electrostatic motor. So for introduction for what is an electrostatic motor? Is convert electrical energy to mechanical energy using Coulomb law. Electrostatic force is proportional to the charge magnitude, inversely proportional to the square of the separation distance. This force enable attraction and repulsion between the stator and the rotor electrode. To using finite elements analysis. Electric field was caused by the charge to move the rotor from high to low potential area. So as you can see from here, going this way, and there's no charges over here. The FEM did not account for any friction, misalignment, resistivity, environmental factor, or charge leakage. So any real world application, it did not apply to this. And so it was overestimating the torque result compared to our result, where our result was a lot lower than the simulation result. The FEM result predict as gradual and smooth decrease in torque as the state of separation increase. But during our paper, it was similar to that, but is as the 3 centimeter it completely dropped off to zero, and so you wouldn't be able to see the toilet paper spin at all. And so some application of the electrostatic motor is microelectromechanical system, right? Anything that's smaller, having less inertia or low inertia will have a very high advantage of this, right? Medical device need low weight, low magnet signature component, any implant actuator, any nanotechnology that is not using magnetic material, right? At the same time, high voltage environment. So if that is doesn't need magnetic field or doesn't want magnetic field, you can use this application for various of thing in high voltage environment that wouldn't affect the voltage that's surrounded by it. Then our next slide would be the demonstration for, and then Brian will run you guys through that.
Hello, my name is Ryan Cassida, and now we will be doing our demonstration of our electrostatic motor. Here we have a power supply, which will be set to 2.6 volts for input, and a pulse generator, which will help step up that voltage to 60 kilovolts. You can find these relatively cheaply online, and although we did tests and we confirmed that this is outputting approximately 60 kilovolts, although what might be running through the system might be slightly less due to resistance and other factors. Here are the stators. So here's the positively charged electrode or stator, and here's the ground. You can use negative, but in this test, we will be using just ground. In the middle is the rotor. It has 4 blades or conducting surfaces. And due to electrostatic motors having such low torque, in lieu of bearings, we decided to just go with a magnet here to help minimize friction to allow it to spin easier. As you can see, it spins quite freely. Now, when the rotor blade is by the positive stator here, it is charged, and because light charges repel, this buildup of charges start to rotate the rotor here. And once it comes to the grounded side, it starts to discharge, which then continues the cycle. Now let's see it run. Some disadvantages of an electrostatic motor is that it requires very high voltage and produces very little torque. They're also easily affected by humidity and other environmental factors,